Okay, good day, everybody. I'm gonna do some narrating. Um, let me. I start the video out. This was just me having trouble getting everything going, so I'm gonna sort of just fast forward the video a little bit. So I'm gonna go quiet until I get going. So let's fast forward. So again, this is just me having trouble getting things going. Um, so let's see if we can fast forward a little bit. Um, I'm gonna go quiet for a bit. Okay. I'm gonna go quiet all the way until I get the math going. So fast forward the video all the way to the part where I get the math going. Sorry about the little beep hiccup here. Um, well, I don't guess it's going to let me fast forward, but we'll get here. Okay, here's some math. Okay, so we get going a little bit here. So if you add two negative numbers, like negative 30, I started explaining it here. It didn't record my audio yesterday to my chagrin. But if you add like two negatives, like negative 36 and negative 53, uh, what what happens is you end up you add 36 and 53, and you'll get 50 89. No, excuse me, 89, and you'll stick the negative on the 89. So you'll add 36 and 53, get 89, but you'll have to remember to stick the minus sign on them. And that's what I'm fixing to explain here. Or that's what I did explain here. It didn't record my audio yesterday, and that's really, really annoying. Um, so I'll just have to bide my time and let it get there. Um, but now here I have technical trouble again. It just is what it is. So again, some technical trouble. But we just have to sort of wait here. I have irritating tech issues. So let's just go quiet for a minute. The math will start. Um, I did too much work yesterday to lose this guy. So I guess I ought to have the patience to sit here for. Here we go. Negative 36 plus negative 53. That's going to equal negative 89. I explain it here. It's coming up. So what you do, you add 36 to 53. You'll get 89 by classic addition. But now because you're adding two negatives, you're going to have to attach on a minus sign. Because after all, you are adding two negative numbers. So you're going to have to account for that. So you're going to have negative 89 because when you do the original problem here, right? So it's negative 89. And I concluded that then I said my audio would have been recorded, but it was not. So anyway, but maybe this audio will be. I guess it's my things happen, right? That's just life. But now here, I get some more tech issues. It takes me a minute to switch between, but I'm going to do negative 36 plus 54. As it turns out, I could have moved more effectively between boards, but I was just getting used to this thing. Here I was doing a lot of, I was kind of getting used to the tech. I was learning my way here. So I wasted a little bit of time here, as you can tell. But we'll get there. It won't let me fast forward. Yeah, this is me from yesterday again, wasting time. but not for malice. I just didn't know what I was doing with the tech, but I kind of do now. I learned a lot this morning. This is me finding my eraser icon and all that. Okay, so now negative 36 plus 54. Now, if you add two opposite signs, well, you subtract. But now here I don't do that. I add to the same sign. Negative 3 plus negative 1 is negative 4. They're the same sign, so you do 3 plus 1 is 4. But you got to slap on the negative because, well, it was neg 3 plus neg 1, which is neg 4. Okay, now negative 3 plus neg 1 is neg 4. I do a little comparison here. I kind of take a little side here. It was the mood I was in yesterday. It's hard to recapture your frame of mind from 24 hours ago, but now keep in mind, negative 3 plus negative 1 is the same as negative 3 minus 1. They're the same thing. They're going to give you the same answer because they're the same thing. They mean the same thing. To add a negative is just to subtract the regular thing. To add negative 1 is the same thing as subtracting 1. These both give you negative 4. Right? And that's what I was getting at yesterday here, okay? It just is what it is. But no, that's the rules. That's the rules. And it took me a minute to, well, it's negative 4, but that's what I was hammering at and harping on that didn't get recorded. Okay. And then I kind of give you the basic lowdown here to subtract 3 minus 1, and now I'll go on a different note. To subtract 3 minus 1 is the same thing as saying 3 plus negative 1 is what I should have said here. So that's 3 plus negative 1 is what I guess I'm going to say. Yeah. So it's 3 plus negative 1. Now this is going to equal positive 2. Of course, 3 minus 1 equals 2, right? And hence 3 plus negative 1 would be 2. If you had one thing I harped on, if you have opposite signs, you subtract them and you keep the sign of the number with bigger magnitude. Then I run into tech issues here again. Yeah, I kind of sort of flounder around here for a minute with the tech issues. So I'm having to do this narration, but I'll get there. Floundering around with tech issues. Okay, so neg 36 plus 54, it took me forever to get back and do the original problem, or the second half of the original problem. So neg 36 plus 54. So negative 36 plus 54. By the way, guys, that's 54 minus 36. But what do I say here? Yeah, you can think of that as 54 plus neg 36. Yeah, that's fine. That's 54 minus 36. Yep, there I write it, and which is going to be 18. Yeah, I had to get a grip on that ink pen, I think, but yeah, it's equal to 18. Okay. My tempo was a little weird yesterday because I was getting used to that electronic ink pen. But anyway, so I erased my stuff, and now the next thing I did was negative 1 plus 4. That's just 4 minus 1. By commutativity, that's 4 plus negative 1, right? But addition has commutativity, right? But that's 3. We all know 4 minus 1 is 3, But, hey, that's 4 plus negative 1 because order doesn't matter in addition. Either way, you get 3. Well, now here I kind of paused for a minute, and I must have had a sort of brain freeze or something. I kind of get real still. I got real still, didn't I? But anyway, so 4 minus 1 is 3. 4 minus, now be careful, 4 minus negative 1 is very different. if you have two negatives side by side separated only by a single parenthesis, that turns into 4. 4 plus 1 is 5, and down here on that second line here. Now, 4 minus 1 is 4 plus neg 1. Now, 4 plus neg 1 is 3 up there on the top. Okay, guys, right here, I do 4 minus 1 equals 3. And notice to subtract something, to do classic subtraction, 4 minus 1, that's the same thing as 4 plus neg 1. On the top right, beside the semicolon, 4 plus neg 1. Now on the second line, 4 minus neg, if you subtract a negative, 4 minus negative 1, that's the same thing as 4 plus 1, which is 5. Now guys, here's the thing. If you subtract a negative, that's like forgiving a debt. On the second line and the third line, if you take away a negative, you take away a debt. But on the top line, if you add a negative, aka you subtract, you add on a debt. You either subtract is like taking away money, adding a negative is like adding on a debt. Now I had $2 when I was in debt, when I had that $1 debt, but that person forgave me that dollar debt, so now I've got $3 after the forgiveness. That's what I was harping at here. But anyway, sorry for the quiet, but now 2 plus negative 1, I had $2, but then a $1 debt was added on to me. So that's going to make me poorer, right? I'm going to lose that's like losing $1 because I acquired a $1 debt. So that's 2 minus 1, and that's going to equal 1. And that's what I did yesterday in this video. So 2 minus 1 equals 1. And yeah, to lose $1 is the same thing, can be equivalent as acquiring a $1 debt, right? You can think of them as one and the same thing. Now I'll go quiet for a minute. I don't think I've got this thing on hold. Now 0. Now here's the thing. 0 is the additive identity. 0 minus 2 is 0 plus negative 2, which is negative 2. 0 just leaves you unchanged when you add things to 0. 0, for that reason, is called the additive identity. It doesn't change you, right? 0 is the additive identity. I get to that later, I think. Anyway. Now 5 plus 0 is 5, of course. Again, 0 being the additive identity that it is. Now notice that 5 times 1 is 5. 1 is the multiplicative identity. If we multiply somebody by 1, it doesn't change. I'm just picking on 5 here, but anyway. If you add in 0 and multiply by 1 is unchanged, these are the identities. 0 with respect to addition, 1 with respect to multiplication. The different identities, but it's in different universes. 0 in the additive universe, 1 in the multiplicative universe, the identities. That's what I'm getting at here. And of course, addition and multiplication both commute. You know, you could just as well do 0 plus 5, and you could just as well do 1 times 5, and you get the same thing, namely 5, right? The order you put multiplication in doesn't matter. The order you put addition in does not matter either. Now that is not at all true, unfortunately, for division and subtraction. Order generally matters for those. Now here's destruction. Now for destruction, 5 times 0 is 0. Now 0 is the destroyer when you multiply by it. Now 0 is not the identity at all in multiplication. It's actually quite mean. You know, it's the additive identity, but if you multiply it, it's mean. And because it destroys everything that ruins it, it has no reciprocal. We'll see later why that is. 0 has no chance of having a reciprocal. 0, but here's the thing. If 0 had a reciprocal, it would, let's say it did. 1 over 0 would be the reciprocal. But 0 times 1 over 0 would be 1. But we've already said 0 times anything is 0. That can't happen. So 0 has no multiplicative inverse. It has no multiplicative inverse. And guys, a multiplicative inverse is a reciprocal. They have the same meaning. There is no such thing as 1 over 0. And what we've said here is 1 over 0 does not exist. There's no such thing as 1 over 0. You can't have it. Now, by multiplicative inverse, I'm talking about reciprocal. I'm turning the fraction upside down. So I'm writing, okay, multiplicative inverse, like 2/5. The multiplicative inverse of 2/5 would be 5 over 2. The multiplicative inverse of negative 2/5 would be negative 5 over 2. So here we go. The multiplicative inverse of 2/3 would be 3 over 2. The multiplicative inverse of negative 2/3 would be negative 3 over 2. Like the multiplicative inverse of the number 5 would be 1/5. Because remember, 5 is 5 over 1, right? So 5 over 1 times 1/5 is 1. You multiply it to the multiplicative identity, right? Or if you the original number times its multiplicative inverse multiplied to 1, and 1 is the multiplicative identity. That's what I was getting at there. Reciprocal is the multiplicative inverse. Now the negative is the additive inverse, and that's what I'm getting at here. Now 0 is fine and dandy here. Nothing wrong at all with 0. 0 is a crucial player. 0 is its own additive inverse. And by the way, guys, 1 is its own multiplicative inverse. I didn't really harp on that much. But let's do additive here. Now, like if you do negative 1/4, the positive 1/4 is its additive inverse. They add to 0. They are negative and positive 1/4 are mutually inverses in the additive world, right? Now, commutativity, A plus B is B plus A. Like 5 plus negative 6 is the same as negative 6 plus 5. And they're both equal to neg 1. Sure. Yeah, that's commutativity. Particularly, I should say of addition here, you guys could get on to me a little bit here. Yesterday I got clumsy. I was incomplete. I wasn't wrong. I was incomplete. I really should say commutativity of addition. Because, there's also another guy called commutativity of multiplication. One moment, guys. Okay, guys, I'm back. Commutativity, yeah, it just says A plus B equals B plus A. And yesterday, my plus sign here was very ugly. But this is a plus sign. It's A plus B equals B plus A. And that plus sign is very ugly on that right side of the equal sign. It is B plus A over there. And now for multiplication, I did do commutativity multiplication. There's commutativity multiplication as well, and that's A times B equals B times A. There's two different commutativities, one for addition and one for multiplication. You can, that just says it doesn't matter who you put on the left and who you put on the right, when you do either process. But yeah. It's like, you could put neg 1, like here, you could put neg 1 on the left and negative 3 on the right, or vice versa. You got to have the same operation. You got to keep it plus. Or if you're using plus, you got to stay with plus. If you're using times, you got to stay with times. But anyway, you get the gist. That's what I was getting at yesterday when I recorded this video. But yeah. Now, guys, yesterday I alluded to the fact 5 minus 6 is the negation of 6 minus 5. Anytime you do like A minus B is the negation of B minus A, but division, 6 divided by 5 is the reciprocal of 5 divided by 6. So notice these are inverses. They don't commute, but there is a relationship. You get the inverses, as it turns out, right? Even though we didn't commute, Now, 1 minus 5 is negative 4. Negative 4 minus 8 down on the second line is neg 12. So 1 minus 5 is neg 4. You have $1, you lose $5. That's neg 4. So 1 plus neg 5, that's like accruing a $5 debt. So 1 plus neg 5 is neg 4. And I almost forgot to put my minus sign yesterday. So negative 4 there. So it's negative 4. So they're up. Now I note that the opposite of 5 minus 1 is 1 minus 5. Again, I just kind of note that. Now, negative 4 minus 8, again, that's negative 4 plus negative 8. And that would be negative 12. Remember, if you add two negatives, you add the 4 and the 8, get the 12, then you smack on the negative. I almost stay too long here, don't I? So yeah, I almost overdwell on this, but I guess it's good that I did a plethora of examples. So now 3 minus negative 7, that's 3 plus 7, which is 10. And negative 2 minus neg 3 is neg 2 plus 3. That's 3 minus 2, that's 1. Yep. I don't know if I don't know if I did that example or if I decided to just skip on and move along, but anyway. So that's 10 for the first one, 1 for the second one. Yeah, okay, I did go through it. Okay, that's good. So minus a negative is plus, and 3 plus 7 is 10. That's great. Because remember, if you subtract a negative, you're taking away a debt. You're making the person better off, richer. And we're doing that in both cases. I came in with positive $3. I actually lose a debt, and that was with the debt, but I lose a $7 debt. I'm $10 now. Now I come in with a $2 debt. I shave off a $3 debt. I gain $3, in other words. I'm actually 3 minus 2 equals positive 1 to the good, right? That's what's going on there. Now it kind of gets redundant from here. If I come in with a $9 debt, I shave off a $3 debt. I'm still in debt, but only by $6. So that would be negative 6. And now the next one, I come in with a $47 debt, but I gain a $35 debt. I take on a $35 debt, so I'm worse off. Remember, you add 47 and 35, that would be 82, but that'd be negative 82, right? I'm further in debt on that second problem there. Negative 82. Now multiplying negatives and divide negatives is different. Debt doesn't really work as well there. You just have to remember the rules. And here we go. The same signs, if you multiply the two things with the same signs, you stay positive. So like two positives multiplied to a positive, as we know. Two negatives multiplied to a positive. And that may feel strange, but it's actually true. It is true. So negative 8 times negative 5. And by the way, don't subtract. This notation means to multiply. You got to multiply. So it's negative 8 times negative 5. That's positive 40. So it's positive 40. Because two negatives multiply to a positive. Now, negative 8 times positive 5. Now, be careful here. Opposite signs multiply to a negative. So that's going to be negative 40. I about messed up here and forgot the minus sign. So it's negative 40. Okay. And if there are two opposites, they multiply to the negative. Now dividing is analogous. Two opposite signs are negative. So that's negative 3 there. And two same signs are positive. The sign rules are the same for dividing. So neg 6 divided by 2 is neg 3. Now, and likewise, you can write divide in fractional notation. Remember, all a fraction bar is glorified dividing. That's negative 6 numerator divided by denominator 2, and that's negative 3. Let's see, I kind of go quiet mouse here. Let's see, I must have been trying to figure out what I was going to do next here. Let's see. Yeah, I go quiet for a while. Well, what am I doing? So here we go, negative 3 over 2. Yeah, it doesn't matter where you put the negative sign. You can put it out to the side. You could put it up top. You could put it on the bottom. And so the negative sign is one of the very few things that's loose like that. Most things are not that loose. The only things that are that loose are ones, negative ones, and minus signs. Most other things are not going to be that loose. They're just not going to be. Now you can yank a lot of things out to the side that you can multiplicatively you can put. Now we're only talking multiplicative anyway. What's going on here is negative 3 over 2. That is negative 1 times the 3 over the 2. So that's going to be 3 over neg 1 times the 2. These are all the same. These are negative 3 halves, right? I did this just for, and notice you can, this flexibility only applies to 1 and neg 1 and minus signs. So that's what I was getting at yesterday when I did this video. And that's what I meant by that little footnote down there. This flexibility doesn't really apply to anything else. So negative signs, ones and negative ones. Now for other things, you got to be a lot more careful. Now for other things, you can yank numerator things out to the side, but not denominator things. And here, that's what I'm getting at right here. Numerator, yes. Denominator, no. So like that 7, since it's in the top numerator, yes, you can yank it out to the side. And that's multiplicative, like 7 times 3 halves. I'm just flexing my muscles and showing what I can do, right? And indeed, guys, that 7 can be thought of as 7 over 1, right? So I'm multiplying 7 over 1 times 3 halves is what I'm doing there, right? To get 21 halves. I'm just showcasing what I can do with fractional multiplication, right? And I picked on the 7, but I could just as well have taken out the 3 if I'd have wanted to. The 7 is not sacrosanct, right? Just letting y'all know. But anyway, another thing I could do is take a footnote. Well, we have 7 times 3, the whole thing over 2. And what did I do? I'm giving y'all what I can do with fractions. Now, multiplying is a beauty. Adding is not so nice. But anyway, so just letting y'all see. I can take out the 7, so it's 7 times. So that's 7 over 1 times 3 over 2. Hey guys, I could also do this. I could do 7 times 3 times a half. Right? So I could do 7 times 3 times a half. Just to let y'all know that. I don't know if I wrote that down or not. But anyway, and this is just a footnote. 7 is the same thing as 7 over 1. I was kind of harping on that yesterday. And if when you multiply fractions, top times top, bottom times bottom. And another thing I harped on, if you stick in an even quantity of negative ones, you won't change. You can stick these negative ones down here and be okay. There's no reason to do so. No reason at all. But you can. Just because you can doesn't necessarily mean you should, but just so it's an even multiplicative quantity. Something. But anyway. Now, guys, yeah, here we go. Here's the beauty. You can write this as 7 times 3 times a half. That's just 21 times a half by associativity, right? Associativity of multiplication. You can do all sorts of things with fractional multiplication. It blow your mind what you can do. Yeah, 21 times a half. And again, that's 21 halves, the original. And here I kind of have to play around with the technology just a little bit. Yeah, that kind of gets old, but I just have to. Yeah, I kind of get lost in the technology here, so just bear with me. Negative 8 times negative 5 is positive 40. And 18 divided by negative 6 is negative 3, right? By the rules that we've done here. So yeah, 18 divided by neg 6. That's the fraction. Now that negative sign, we can just take it out to the side if we like. But you know, we get neg 3, right? So minus sine 3. And yep, and indeed, here I go. I wrote this in fractional notation, and that's neg 3, or minus sine 3. Yeah. Now here are exponents. Now 4 cubed, remember what it means to cube something, or raise something to the third power. The exponent tells you how many times you're going to multiply the base. The base was 4, the exponent is 3. That means you're going to do 4 times 4 times 4. So yeah, that tells, and I kind of alluded to that here. So how many times we need to multiply the base, which is 4. So it's going to be 4 times 4 times 4. And see if you get 64. 16 times the third 4. And yeah, that's going to be 64. Sure. That's exponents for you. And I go, what do I do next? Associativity. Now there's 2 associativities. Associativity of addition and associativity of multiplication. And I use the shorthand plus sign to denote addition and the shorthand times sign to denote multiplication. So A plus, now if you, parentheses means you add B plus C first. You get that resultant and add that result to A. But associativity says it doesn't matter. I could have just as well on this other side added A plus B first in parentheses, and then afterwards added that result to C. And there's the analog to multiplication. I can do the analogous thing to multiplication that I did to addition. Okay. So I should do a concrete example. So if you have 3 plus, let's just say 5 plus, whatever number I used. Now, an example doesn't prove the rule true, but it motivates it. So I got 3. Associativity just says I could do the 5 plus 6 first in parentheses, or I could do the 3 plus 5 first. The parentheses tell me what I do first. Okay. Now, I actually go through and bear it out here. So that's 3 plus the 11, and that's, 14, right? I should get 14 either way I cut it, though. And I'm going to. I can do it right now, I'm going to. So that's 3 plus 5 plus 6. So it's 8 plus 6, and that is 14. Well, now multiplication will behave just as nicely no matter who you pick. If we do 2 times 3 first, the parentheses indicating as much. We get 6 times the 7, and, that's going to be 42. It's going to work out both ways. Now, on the other end of the vertical bar, I do the 3 times 7 first. And so it's 2 times 21, and that's going to be 42. I didn't really need to put parentheses around that 21 there, but I just did. Just a mood thing, I guess. Nothing wrong with it, but it wasn't necessary. Now, distributivity. Now, distributivity involves time multiplying and adding, and the order kind of matters. The time sign really needs to be where it is, and the plus sign needs to be where it is. In every sense of the word, they need to be where they are. So A times the parentheses sum of B and C equals A times B plus A times C. So I do an example up here at the top right, 5 times the parentheses sum of 6 plus 2. Now we know about PEMDAS, that's 5 times 8, and so it's 40. But guys, PEMDAS kind of takes away our ability to use the beauty of the distributive rule. So I go down here at the bottom of the page, and I do the distributive. I better get the same thing. So I do 5 times the 6 plus 5 times the 2, deploying distributivity. That's 30 plus 10. 5 times 6 is 30. The 5 times the 2 is the 10. Then I do 30 plus 10, get 40. The A was the 5. The B was, let's just say 6. The C was the 2. Notice I got 40 both ways. I got the same thing. I go kind of quiet here, don't I? Yeah. Now, inverses, I thought it did that already. I don't know why I'm harping on it again. You have multiplicative. Now, as long as you're not equal to 0, they're just reciprocals, right? A times B, A over B times B over A is 1. Now, 0 doesn't have an inverse. And additive inverse is just your negative. J plus negative J is equal to the additive identity 0. Yeah. So 0 is the additive identity, 1 is the multiplicative identity. Anyhow, I kind of just reviewed that, I guess. We've kind of already been here before. And again, I just harping now. 0 can't, remember 0 can't have an inverse. There is no, 1 over 0, right? So here, I finally decided to move on. I think I decided, I'd had enough of adding negatives. It was time to kind of scoot on down the highway. And rightfully so. I think it was time. Yeah, those I left to y'all. See if you get -3 for the first one, -24 for the second one. Yeah, this one, now you do PEMDAS. Now, please excuse my dear Aunt Sally PEMDAS. Now, I do need to harp on PEMDAS a little bit, and I should have harped on it here. Please excuse. Please excuse. Now, there is some nuances and subtleties to PEMDAS. So it's please, and then excuse, and then my dear. Now, my dear, they come together. M and D come together. M is not really higher than D. M and D are in the same category. And Aunt Sally, the A and the S, A is not really higher than S, or vice versa. They come together too. Here's the thing. Parentheses is strictly highest. Exponent is strictly second category. Now, multiplication and division are brother and sister. They're strictly third category. Addition and subtraction are strictly lowest category, right? And if you don't have a tiebreaker, you read them left to right. If there's nothing else to break the tie. Like if you have multiplying and dividing. If all you have is multiplying and dividing, you read it left to right. And if all you have is adding and subtracting, you read it left to right. Like if there's no parentheses, no exponents, and nothing else. If all you have is adding and subtracting, you read it left to right. Or if all you have is multiplying and dividing, you read it left to right. That's the tiebreaker. This is what PEMDAS really is. So PEMDAS is kind of a broken road a little bit. It's PE and then MD, then AS. It's please, then separate excuse, then my dear together, then Aunt Sally together. So for example, if we have 5 times 3 plus 4, well, you got to multiply first, evidently. So 15 plus 4, and that's 19. I'm doing that at the top of the page. You got to multiply first. Now, multiplying is strictly better than adding, right? It's true, multiplying is sternly better than adding. But however, guys, if you put parentheses around 3 plus 4, that changes everything. You don't have the same guy anymore. You've got to do with the 3 plus 4 first because you're doing parentheses. You got to get 3 plus 4 is 7. 7 times 5 is 35. Because it's not the same thing anymore. You've put parentheses around 3 plus 4. You've given it the top hierarchy. P trumps everything, right? So yeah, this is not the same as this, right? You get 35 here versus 19 here. And we don't expect it to be the same thing. Because parentheses change everything, right? Times does trump adding, but that's only good if there's no parentheses around. And I kind of erased stuff here, and I'm sort of playing around. I'm trying to think of another example. So now parentheses. Now remember, you can do distributivity here too, but I just kind of chose to do. It's 5 times. You got to do the parentheses first. That's 7. 5 times 7 is 35. But you can do distributivity. Remember. And you better get 35. This is the distributivity. 5 times 3 plus 5 times 4. That's going to be, you do, now here about PEMDAS, you do 5 times 3 is 15. And then 5 times 4 is 20. You add the 15 and 20. And you get 35 again. Now these are better match, right? Or we wouldn't be consistent otherwise. Okay. So, yeah. That wasn't so much PEMDAS as it was me. Well, it was PEMDAS. It was a combination of parentheses PEMDAS and me associating it or combining that in with distributivity. And I kind of play around here. I'm thinking of another example from when I was doing this yesterday. Now, if you have 5 plus 4 divided by 2 with no parentheses, now dividing strictly trumps adding. You got to do the divide first. So you got to do 4 divided by 2 to get 2. Then you do 5 plus 2 to get 7. And you have to do it this way. You don't have a choice. It has to be done this way, right? So yeah, you got to do it that way. Dividing sternly trumps adding, right? Because dividing is in the third tier, adding is in the lowest tier. Now, however, if you do parentheses around the 5 plus 4, that changes everything. Because parentheses come first, they give you 9. 9 divided by 2, that's the fraction 9 halves. You can stop there. That's good enough. You could write that as 4.5 or 4.5, but that's not really necessary anyway. 4.5, 4.5. But just leave it 9 halves, guys. You leave it 9 halves. I actually love him. I like improper fractions better than a lot mixed number, and a lot better than a lot decimal. So anyway, now 5 plus 4 divided by 2, so that was 5 plus 2, which is 7. That's just a recap. What I said a minute ago. Was I hammering at something? Yeah, I was going to use that, I guess, to get at something. So 5 times, I was trying to think. I think my brain was spinning at this point. So it's 5 times 6 squared. So it's 5 times. Now you got to do exponents first. Exponents trump multiplication. So it's 5 times 36. But 5 times 36 is 180. You got to do it in that order because exponents are strictly higher than multiplying, right? That's what I was getting at there. You got to pay attention to the hierarchies, right? Now, the square of 5 times 6. Now, guys, here's another example. It's not the same thing. Now, notice here, this is very different. You got to do what's in parentheses first. So parentheses give me 30. But parentheses trump exponents. So I got 30 squared. That's 900. 30 times 30, right? So notice that's very different. And we expect it to be because parentheses often change things, right? Parentheses outdo exponents, right, in the hierarchy. Yeah, and that's what I was getting to with that one yesterday. And I erase here and I kind of go quiet for a minute. Get my thoughts together, I guess. Now, parentheses are going to trump anything. So 7 minus 5 is, we have to do that procedure first because it's a parentheses procedure. So that's going to be parentheses trump exponents. So it's going to be 2 cubed, or 2 to the third power. So it's 2 to the third, and 2 times 2 times 2 is 8. However, be careful. If you do 7 minus the cube of 5, exponents trump subtracting. There's no parentheses here. That's just 7 minus the cube of 5. That's 7 minus 125. Subtraction's the last thing we'll do here. Exponents trump subtraction. So 7 minus 125. Now that's going to be a negative number. That's going to be, 125 minus 7 is 118, but we're going to get the negative of that because we're going backwards. So it's negative 118. And so notice that those parentheses change things, don't they? And I think I finally gave in. Now, I have to do one example I do in a minute is fractions. And in fractions, there's a hidden message, a subliminal idea that you had to get used to. You keep numerator and denominator separate. That's what I'm going to get to here in a second. But let's see. Well, so I've erased it. I don't know why I didn't pull up another slide, but oh well. I guess yesterday was yesterday, and what's done is done. Now here's a pretty rule. X, y, the product of x times y, that means I'm multiplying them. X times y raised to the power of n is x to the n times y to the n. I'm multiplying them. And that check mark means it's true. Now, x divided by y to the n, and I think oops, did I make a boo? That should be to the n power. I should have put a power of n here, guys. I didn't catch that. Oh, I forgot my n here. No, that's not quite true. I forgot my n power. That's x over y to the n. Those parentheses should have an n by them. Did I ever correct myself? No. Guys, there should be an n power by that x divided by y. Those parentheses there should have an n on them. Well, I forgot to put the n on my x divided by y. So x over y to the n power is x to the n over y to the n. I got the right side of that. On the bottom left, guys, that x divided by y, that parentheses should have an n. The parentheses are good, but there should be an n power there. It's analogous to what I did on the top left. Otherwise, I'm good. And notice, guys, on the bottom right, where I put the frowny sign, that rule is no good for adding and subtracting. So adding and subtracting, you just can't do it. But for multiplying and dividing, you can do it. Just correct my typographical error. That's the obvious typographical error. Now, like 5 times 6 to the 2 power, that would be, well, by PEMDAS, that's 30 to the 2 power, which is 900, 30 times 30. But let's see if we can use that rule. So 5 to the 2 times 6 to the 2. What about that? That's our rule. That's 25 times 36, and I can tell you that is 900. Now, so 900, yep, and that will always work by the rule. Okay. Now, an example doesn't prove a rule, but it does motivate it nicely, right? Now, for the fractional rule, which with the typo that needed corrected, but y'all can, so 5 halves to the n power, n is 3. So that's going to be, now by the definition, that's 5 halves times 5 halves times 5 halves. Now remember, you just do top times top times top over bottom times bottom times bottom. 5 times 5 times 5. On the top, that's 125. And on the bottom, 2 times 2 times 2 is 8. So now 5 cubed, but hey, guys, look at the bottom left. 5 cubed over 2 cubed. That will also give you 125 over 8. I about waited too long to speak, sorry. Yeah, 5 cubed over 2 cubed is the same thing. So the rule checks out for that example. And again, that example motivates it. Now I'm going to give you a non-example. Now, by PEMDAS here, we do 5 plus 1 in parentheses first to get the 6, then square the 6 to get 36. But I'm showing you this, it's no good for adding. However, 5 squared plus 1 squared is not at all going to be 6. Not at all. It's actually going to be 25 plus 1. We do exponents first by PEMDAS, and then we add afterwards. We get 26. So notice, 26 versus 36, I mean. So they're not the same thing. So this rule is no good for adding. That's what I indicated a minute ago. It's only good for multiplying and dividing. It's no good for adding or subtracting, right? You can't say the square of a plus b is equal to the sum of the squares. It doesn't work, and we don't expect it to. But now I kind of sort of gather my thoughts here. Now that was a left to right problem. You just go left to right. And this is that altitude problem. And I ended up messing up on part 2 there. I had a little brain burp here. I got part 1 right quickly. On part 1, you're 65 below sea level. I mean, at checkpoint 1, you're 65 below sea level. At checkpoint 2, wait, no, sorry. At checkpoint 2, you're 188 feet below sea level. Now, the top of the hill is 521 feet higher than checkpoint 2. So what you do is you take negative 188 and add positive 521. So neg 188 plus 521. I get it wrong here. I misunderstand the question, but I correct myself pretty fast. It's neg 188 plus 521, whatever that is. It's in the 300s. It's 300 and something something. That's part A. That's all there is to part A. You know, if you're 188 below sea level, you add 521 higher, you're going to be 300 and something above sea level. And this is, I just do classic subtraction here. And I kind of do, yeah. So it's 333. Yeah. I got that right pretty fast. And the second part I got a little silly on. How much higher is checkpoint 4 than checkpoint 1? I write down the wrong number, and that costs me 10 minutes of my time here. It's 2657, but I have a short-term memory issue. I get my 6 and 5 mixed up. I have a copy and paste error here. I have the right idea. My heart is in the right place. So look what I did here, guys. I wrote down the wrong number. So you want to. I did the right procedure, but that should be 2657, and that's going to cost me about 5 or 10 minutes of my time here. So just and I'm going to get it wrong for that for that reason. It tells me I'm wrong. It doesn't even tell me why, and I get a little insecure. I have to sort of go find what I did wrong. It's because of that little copy and paste error. It's just a perception error. So that 2567 should be 2657, and just a little silly goof can cause you a lot of grief. But yeah, that's the correct procedure otherwise, right? You add 65. Let's see. If you have the 5 there, 2, I think it's like 2722 or something. Would that make it 2722? Yeah, that would. The correct answer, the first guy's right. The second guy should be 2722. But I eventually find out in a minute what I did wrong. You get clumsy, and there you go. And I kind of harp on here, so I'm just going to be quiet for a second and we just got to get through this part of the video. That's just common sense. An error you'd make it an error that an accountant would make when he's tired and sleepy, right? So here we go. It'd be good if I could. I'm too lazy to trim this part of the video. It just takes too long to trim. So it's not that long. We'll bear it up. And I get it wrong, and it's because of part. And I go over here, I'm trying to fish out what I did wrong, and no, that was it. It was that 2657. So just a minute, let me go quiet. Blah, blah. Yeah. Those are the most annoying things. I eventually, I have to just mess around for a while until, yeah, the 333, I look at it, then I come over here and I finally find out what I did. Come on, come on, come on. Yeah. Perception can be so bad, right? Is it just me, or are it's transcribing hard sometimes? Yep, here, I finally found it. Yeah, and that was it. And that should give me 2722, right? And I point out what I did wrong there. And I point out what needed to be done. And yeah, sure enough. Um, and yeah, right. We kind of wish I could move on with it. Let's go. Yeah, 2722. And that's going to fix it. So 2722. And yeah. So that's how much higher up checkpoint 4 is than checkpoint 1, right? You do what you're doing is 2657 minus a negative 65, but that turns into plus 65. Now, guys, the first guy on this problem right here, changing gears here, 0 divided by 7 is 0. That's fine. Nothing wrong with that at all for the first guy, just for the first. Now, for that second one, 6 divided by 0, you can't, that's undefined. You can't put 0 on the right-hand side, ever. And putting 0 on the left is okay, just so you don't put 0 on the right. So here's a case in point. 0 divided by 7 is the fraction that's the same as putting 0 on the numerator. 0 over 7, that's just 0. But now, guys, 7 divided by 0, that's no go. That's undefined. No go means undefined, right? Now, furthermore, there's another bad guy. 0 divided by 0. If even that guy we don't like, that's also no go. We can't have that either. That's no good either. It's also undefined. We're never ever allowed to put 0 on the denominator. We don't like, in other words, we don't like the fraction 0 over 0. Yeah, because there's just no way to define it. 0 doesn't have an inverse, right? But that's what's happening. And there we go. Now, this is easy. Just remember, you're multiplying. You're not subtracting or adding here at all. Not at all. You're multiplying and only multiplying. That's 2 times neg 4 times neg 1. And you should get an answer of positive 8. Guys, just remember, you're not subtracting anything. You're just multiplying. There's a subliminal message. There's a subliminal time sign there. So 2 times neg 4 times neg 1. So those subliminal messages, those time signs. And that'll give you positive 8. Because remember, if you have an even amount of minus signs, you'll end up being positive when you're done. And if you have an odd amount of minus signs, you'll end up being negative when you're done. And so, yeah. Now here, now careful. Now 2 minus 4, that's, remember from a long time ago, that's 2 plus negative 4. We really are subtracting here. That'd be neg 2. However, contrast that greatly. This is 2 times neg 4. This is not the same thing at all. Right? We're multiplying. See, the notation can really throw you for those parentheses change things. The parentheses indicates that I'm multiplying, and students trip on that sometimes. So just watch out. That it can be a tripwire for students. That parenthesis there means that we're timesing. That's what I was getting at yesterday. Now here's magnitude, absolute value, which we call magnitude. If you're positive, you stay positive. If you're negative, you'll become positive. So the first guy's 12, the second guy's 6. So the absolute value, which we call magnitude sometimes, it's just the positive version of the number. And if you're positive, you'll just stay that way. If you're negative, you'll become positive. And of course, now 0 stays 0. Absolute value of 0 is 0. That's kind of the oddball. But anyway. But anyway, absolute value of -7 is positive 7. The absolute value of +7 is still positive 7. If you're negative, you go positive. If you're positive, you stay positive. That's what magnitude does for you. So the first guy's 12. The second guy just stays 6. You just want to get the positive version. Now here's the subliminal message I was talking about. There's a hidden message. The numerator, technically speaking, there's parentheses around the entire numerator, and there's a separate set of parentheses around the entire denominator. Always. But we seldom ever write them that way because we don't need to. What we usually do is just take it as understood that we do the numerator separate and we do the denominator separate. And we wait to the very bitter end to do the dividing. But you may ask, well, why do we wait to the bitter end? Because there's hidden parentheses that don't get written. A separate set around the numerator and another separate set around the denominator. And because of those two separate sets, that's why we do that dividing last. So here I'm telling you, I'm writing it down, fractions have that hidden message. You put parentheses around both. They're separate sets, though. You put a separate set around the numerator and a disjoint separate set around the denominator. They're mutually disjoint, like they're separate. And I'm going to illustrate that here and real soon. We keep them separate, keep them those pair of parentheses. Now remember, you're like, well, can we write this? And that's particularly pertinent if you change a fraction bar to a 5th grade division by bar. That's when that becomes really important and amplified. So notice here, if I try to use that bar, now 2 plus 6 squared, I could kind of get away without doing that separate set there. But if I try to do that on that denominator, I'm going to get in a world of trouble. Because you have to have a parenthesis around that denominator. It's because you've got to divide by the whole Monty. You've got to divide by everything going on down there. You can't just divide by the pieces. You got to divide by the whole Monty. But really, for the sake of good table manners, I'm going to put a separate set around the numerator right now. And that's where I drew that arrow. And I drew that right arrow for the denominator. So there's a separate set around the numerator, left arrow, and a separate set right arrow around the denominator. And then there's the fraction bar, which I've now written as a 5th grade or 6th grade division by symbol, right? Guys, if you don't use those parentheses, you will get burned. And let me tell you right now, most of the time, you're going to need both pairs. In general, you need both sets of parentheses. Because if you leave off either set of parentheses, it will haunt you, and you'll get the wrong answer. There'll be little problems like this where you could make an exception to like the numerator, but that's rare. Most of the time, you need both sets. It's good just to if you're going to write it in this 6th grade form, it's good just to go ahead and just write both global sets like I did. So we got 8 squared in parentheses divided by next parentheses. And then inside those parentheses, you do PEMDAS inside those. And you go inside these parentheses to the right 4 times 9 has to come before the subtraction. So we do 36, and then the subtraction minus 4, right? Because you gotta multiply before you subtract. Notice I'm keeping the numerator. The numerator is the guy on the left. The denominator is the guy on the right. I'm keeping the universes separate. The numerator universe separated off to the left. The denominator universe separated off to the right. And I want to keep it that way for a long time, or at least to the bitter end. Now, that will only change at the very end of the problem. Anyway, 8 squared is 64. I can drop the parentheses, but only now that I've got a single digit number. Or excuse me, only now that I've got a definitive number, 64. Now divided by, now you got to do what's in parentheses. 36 minus 4 is 32. It's in parentheses. You got to do parentheses by PEMDAS. 32. So we got 64 divided by 32. And that equals 2. Right. Check it and see. You can write that in fraction mode. 64 up top divided by 32 on the bottom. But notice we had to wait to the very end to do that fraction bar, right? And that reduces to 2 over 1, which is 2. That reduces to 2. 2 over 1 is 2. But guys, see that subliminal message? A lot of people are like, well, PEMDAS is violated. No, it's not. It's really okay. It just feels that way because of those subliminal parentheses that you don't see, right? And I do another problem. Let's say that I have 2 plus 6 squared divided by, well, what am I up to here? Am I doing a rehash? 4 times 9. No, there must be a reason why I rehash this guy. So 4 times 9 and then minus 4. So that equals, I do it in fraction mode. Now I'm going to go from 5th grade mode to fraction mode. I see what I'm doing. But notice those subliminal parentheses. They're here. And they're up here. But now we don't have to write them. We can just get rid of them and just keep the universes separate. Finish off the numerator by PEMDAS and PEMDAS the denominator and get 32. And yep, there you are, 64 over 32. Are we consistent? Yeah, we get 2. That's exactly the stuff we got earlier. But yeah. So PEMDAS is alive and well. Now this next problem here, with negative signs and exponents, we know what to do. You just have to be careful about insiders and outsiders. That's what I kind of get at here. This whole business about inside negative and outside negative. These are inside negatives. Now, the cube of neg 2 is just negative 2 times negative 2 times negative 2, and that's negative 8. Let's give that a look. I'm going to write it down here. Now I kind of go on a side note. So I wish, well, it's okay. Here's a side note. Negative 1 is the multiplicative essence of being negative. If you raise negative 1 to an odd exponent, you stay negative, negative 1. A negative number raised to an odd power will give you another negative number in general. Negative 1 raised to an even power will give you positive 1, the multiplicative essence of positivity. Okay, so, well, now, here's the thing. If we take neg 2 and we raise it to an odd power, like 3, we'll get another odd number back. It won't be neg 2, but it'll be, we get a negative number. Excuse me, guys. We get a negative number back. So we get negative 8. Notice, negative 1 to odd is negative. So negative sign to odd is negative. Negative sign to even is positive. So negative sign to odd is negative. We just do 2 cubed is 8, and we follow this rule up here to get the minus sign. That's what I'm getting at. And indeed, guys, negative 2 parentheses cubed. Notice that parentheses. That parentheses means I'm I'm cubing all of neg 2. I'm cubing the 2 and the negative. So it's negative 2 times negative 2 times negative 2. That's negative 8. You could look at it like that. Or you could just, you could say, look, do 2 cubed. And since everybody is in parentheses, it's going to be the negation of that. So it's negative 8. Now, this did hinge on, everybody being in the parentheses. Everything kind of goes out the window if they're not. And that's what I'm talking about here, so watch out. If you have negatives on the outside of the parentheses, life gets a little bit harder. I can't use that rule. It doesn't apply. So like now, if I square negative 1, I get positive 1. Sure, that's great. That's dandy. But now be careful. That's not the same thing as the negation of 1 squared. Because that second guy that I wrote on the second line, that's still negative 1. And students mess this up in their calculators too. That's still neg 1. Because that second line is the negation of 1 squared. Because you had to do PEMDAS. You square the 1 first, and then you negate. In other words, you're multiplying by neg 1. But you got to square 1 first, which is 1, and multiply by neg 1. You're still neg 1. You PEMDAS out to neg 1. It's not the same thing. It's not the same meaning. Right? The first guy on the first line is neg 1 times neg 1, which is positive 1. You're not doing the same stuff, right? Now, the second guy would be positive 16. That's negative 4 times itself negative 4. But 2 negatives make positive 16. Now, that's just a sort of an ugly PEMDAS problem. I was not going to do it, then I ended up breaking down and doing it. You got to do the neg 2 cubed first. That would be neg 8, but you minus neg 8, so it's 2 plus 8. In the middle is what's going to happen. But I write it out here. So let's write down the problem. And we got 4 squared there over, 2? Okay. So yeah, I just make sure I wrote it down correctly. So now 2, you got to exponentiate before you ever subtract. Now neg 2 cubed is neg 8, but you're minusing neg 8, so it's minus parentheses neg 8. And plus, now 4 squared is 16. 16 divided by 2. Now, okay, so we've got 2, it turns into plus 8. And then plus, now 16 halves, we need to get that because dividing trumps adding. So it's 8. So now we do 2 plus 8 plus 8. That's 10 plus 8. We're going left to right. And then that's going to be 18. So that's classic PEMDAS, right? And it's kind of sticky PEMDAS, right? But we got there. Anyway, I finished it off, and then did I move on a little bit? Yeah, PEMDAS can get a little sticky. Then I got to adding common denominators and LCD and all that. Now, did I get this covered? I think I decided to break down and cover it. I was not going to cover it. I was getting a little panicky. I was running out of time. But I think I broke down and decided to cover it. I wasted a little time here harping. But let's see. I think I decided to cover it. So let's give it a look. So like if you have 2/3, well, I go into multiplying fractions. Now 2/3 times 4/5. Now if you multiply fractions, well, what about that? 2 times 4 is 8. You do top times top. 2 times the 4 is 8. And bottom times bottom. 3 times the 5 is 15. So numerator times numerator up top, and denominator times other denominator, the 15 on the bottom. 8/15. Now, if if we do, let's say 2/3 times, if you stick in negatives, you just obey the negative rules, you know. If you have 2/3 times, I was debating on what to do here. Let's say 15/4. Now we can do a thing called cross canceling when we multiply fractions. Like we look across the diagonal, and now 2 goes into itself 1 time, and 2 goes into the 4 2 times. Now we look at the other diagonal, the 3 and the 15. Okay, so looking at that other diagonal, come on now. So we look at the other diagonal, 3 goes into itself 1 time, and 3 goes into 15 5 times. But notice something, guys. We can now do top times top and bottom times bottom, but really, y'all see that 1/1? That's just 1. That's that fraction it generated. We just have the 5 over the 2 on that second fraction. That's just 5 halves. Well, yeah, 1 times 5 over 1 times 2, 5 halves. Either way you cut it. That fraction on the left just totally wiped off. 1/1 is 1. Right? The multiplicative identity. Now, if you have 6 over now, sometimes things will reduce down, but they won't reduce down in totality. You know, and it took me a minute to think of this example. I remember I had to sort of go through my head a little bit on this one, so I wasted a little time here. I have to go through my head with this one a little bit. So I have like 6 over, well, yeah, it takes me a minute to kind of get all this formulated. How are y'all?
Good day, sir. How are you?
Doing okay, yeah.
Good.
So it's 6 over 25. And I got 15 over 8. And, well, now what I do is I cross cancel, but it's only piecemeal. Sometimes you can't get like you take out the greatest common factor, but the greatest common factor for the 6 and the 8 is just 2. So you divide by 2, and you get 3 there, and you get 4 there. Now, so that's that diagonal. Now, then I'm going to cut across that other diagonal, and I think I can take out my greatest common factor would definitely, yeah, I actually know it would be 5. Now divide by 5, and you get a 3 on the top right and a 5 on the bottom left. So up top we got 3 times another 3, which is going to be 9. And on the bottom I got 5 times 4, which is 20. So it's 9 over 20. So that's, you know, do you have to cross cancel, guys? No, but it's awful nice because it saves you from having to reduce the fraction later when you're finally done. I highly recommend it. And now sometimes you can't cross cancel. Can you always cross cancel? No. Sometimes you just if you can't cross cancel, just don't. You just can't do it. You just have to just finish it off and just do top times top, bottom times bottom, and be done with it. It won't reduce anyway in that case. Now, how do you multiply mixed numbers? You have to go improper. So you turn 1 1/4 into 5/4. You do 4 times the big one and get 4, and add 4 to the little one up top and get 5. So it's 5/4. I just reminded y'all how to get improper was what I was doing there. So that's 5 over 4. You got to go improper, you won't be able to multiply. And I about messed up, so now hit times. Now for the second guy, you do 5 on the bottom denominator times the 2, you get 10. and then add the 10 plus the 1 up top. That's 11, so it's 11 over the original 5. So there's my other improper fraction, 11/5. But now we multiply them. We can 5 totally wipe out the 5s by cross canceling. And there we go. They just become 1s. 1 times 11 is 11. And 4 times 1 is 4. So that's 11/4. 11 over 4, and we're done. Now, you can stop there. I'm fine with improper fractions, to be honest with you. It won't really reduce anymore. If you want to turn it into a mixed number, that's great. But really, 11 over 4 is good enough. If you love mixed numbers or need a mixed number, it would be 2 remainder 3, so it's 2 3/4. If you want to go that route. But the improper fraction, 11/4, is good enough by me. But mixed number, you might need it in some chemistry applications, but you shouldn't really need it all the time. And here I go through all the big details, and I show y'all how I got that. You just do old-fashioned division, like 4 goes into 11. Well, twice without going over is the best you can do, and remainder 3. It's 2 remainder 3, so it's 2 3/4. Now the least common denominator. I'm inadvertently going to do that here, right? So LCD, least common denominator, and all that. Now 1/2 minus 1/10. So 1/2 minus 1/10. Now adding and subtract. I finally get to adding and subtracting fractions. Now least common denominator. With adding and subtracting fractions, you have to have the same denominator. That was not at all true with multiplying and dividing, right? We didn't even think about that. But with adding and subtracting, that's a big thing. We need the least common denominator, or the least common multiple of the two denominators when we add and subtract fractions. So like if we have 1/2 minus 1/10, we need the least common multiple of the two denominators, or the least common denominator. Well, it would actually be 10 itself. The smallest multiple that 2 and 10 both go into is 10 itself. So now here's what we need to do. We need 10 itself. So I need to multiply, 2 times who is 10, or 2 times, it'd be 5, right? So 2 times 5. But if you multiply by the 2 by 5, you got to multiply that 1 above it by 5. That's just a rule. You just got to do it. So it's 5. 1 times 5 is 5 itself, and 2 times 5 is 10. So that's 5 over 10. Now we don't mess with the 1 over 10. So because it was already good, it already had the 10. So we have 5 over 10 minus 1 over 10. And that would be, now here's the beauty. We can gel together the numerator and get 5 minus 1 over 10. And now we don't mess with the 10, right? Or at least not yet. So we get 4 over 10. So it's 4 over 10. And that's going to, but now we kind of do, we can finally do something. We got 4 over 10. Now we reduce the fraction. Now we get 2/5, right? But we couldn't do anything for a long, long time. So we got 2/5, right? You divide the 4 by 2 and divide the 10 by 2, that's 2/5. So hence, 1/2 minus 1/10 is 2/5, is what we conclude. So I did finally subtracting fractions here. Now 5/8 plus 2/5. Well, least common denominator. It would be 40, right? The 8 on the bottom and the 5 on the bottom. The least common multiple of the two would be 40. So we got to furnish that, and I'm fixing to do that here. I have to. So what was the original problem? It was 5 over 8 plus 2 over 5. And, well, so 5/8 plus 2/5. Now, it's the denominators, they're what I use to get my least common denominator, right? So the 8 on the bottom, which is the only 8 there, and the 5 on the bottom. So my least common denominator would be 8 times 5 is 40. Well, we don't always times them, right? So the least common denominator can be more subtle than that. In this case, it is 8 times 5 because 8 and 5 have no commonality other than 1, which it doesn't matter. So I do times 5. In this case, it is the times 5 times 5, the 8. The two denominators have no kinship besides the obvious 1. So I do times 8. So I do times 5 times 5. You always go directly overhead, right? And if you multiply 5 by 8, you got to multiply the 2 above it by 8. Notice, if you do one thing in red, you got to do the thing directly above it in red. The same thing, right? So that keeps the fraction equivalent. So that would be 25. So that the 5 in black times the 5 in red would be 25. And the 8 times the 5 would be 40. Now the 2 times the 8 in red would be 16. And the 5 times the 8 in red would be 40. Okay, now we're ready to add. We have the common denominator. 25. We can add the 25 plus 16 and gel that together. I just go ahead and just do it, I think. So 25 plus 16, we don't mess with the 40, right? 25 plus 16 would be what, 41? So I do believe, check it and see, yeah, that would be 41. So it's 41 over 40. So that's my final result there. And yeah, you can stop there, guys. 41 over 40 is fine. If you love mixed numbers, that would be 1 and 1 over 40. But anyway, that's not necessary to get a mixed number. And remember, to get a mixed number, like 40 goes into 41 one time with a remainder of 1. That's why it's 1 and 1/40. But here I really do start to run out of time, I think. Yeah, and I think my time is kind of running out at this point. So I think I kind of